Hi everyone, this is Adam again. So today I'm just going to go through what functions are and the different classifications of them. And then in the next video I'm going to go on to kind of transformations and that sort of thing. Okay, so first of all, functions. A function is just something that it takes in a certain number called an input. So an input goes into the function. And then what comes out of it is called an output. Now it's very important that you remember that a function is something that it takes in one number and gives out another. That's very specific. It doesn't take two numbers and gives out one number. It doesn't take one number and give out two numbers. It takes one number and it gives you another one. That's that. Okay? So here what you get is you have input goes to an output. There's another thing called a domain. This is basically all the numbers you can put into the function. So like the domain, they could just say, all right, so you can only plug in the number 1, 2, 3, 4, 5. So your domain in that case would be 1, 2, 3, 4, 5. Your range is all actual outputs. And then you have a codomain, which is just all outputs, period. So a range is basically, sorry, that just looks really messy. So the range is basically, okay, you plug in the whatever numbers, let's just say you plug in 1 and 2 and then you get out whatever. Your codomain is all possible outputs. So you might say, so I'm only plugging in 1 or 2, but your codomain is basically saying, okay, but what if you plugged in all the numbers that you possibly could plug in? Then what would you end up getting? So a range is something like, if I say, you can only plug in the numbers 1 and 2 into the function f of x equals x squared, then your range is just equal to 1 and 4. So if I plug 1 in and square it, I get 1. If I plug 2 in and square 2, I get 4. But your codomain is basically equal to basically all numbers that are greater than, so you know what, I might rewrite that. So all numbers x that are greater than or equal to 0, where x is a real number. Okay, because if I asked you, can you get 9? Yeah, you can get 9 if you plug in 3 squared. So even though I didn't specifically say you could, your codomain is basically just saying what are all the numbers that you could possibly plug in, and what could you possibly get out of it. So in this case, with x squared can go from 0 to up to infinity. So it's just as big as you like. So that's the difference between range and codomain. You won't typically need those, okay? So again, real numbers are just all numbers, okay? So if it's x is an element of R, it's just every number you can think of, okay? And again, if you're a Leaving Cert student listening to this and you're like, what about complex numbers? Yeah, so not complex numbers, but any number that you can think of that doesn't have an imaginary part in it, okay? And if you're in 5th year or in 6th year and you still haven't done complex numbers, then real numbers, as far as you're concerned, is just absolutely everything that can be there, okay? So again, I'll just go through different intervals. So an interval, a to b, written like this with square brackets, this means that x is less than or equal to, okay? If you have round brackets, this means that x cannot be equal to a or b. And then let's say I have one square bracket and one round bracket. Sorry. Like this. This means that x can be a, but it cannot be b. Okay, so the way I remember it is a square bracket. You do 1, 2, 3. And that's the same as doing 1, 2, 3. So you have to do 3 straight lines to do a less than or equal to sign. And doing the square bracket, you also have to do 3. So that's personally how I remember it. So just to be clear, when there's square brackets like this, you have less than or equal to signs. When you have a round bracket like this, you have a strictly less than sign. Okay, so that's all you really need to know about the intervals. All right. Okay. The next thing to do is the composition of functions. Okay. So a composition is basically if you do one after the other, what happens? Okay. So a composition is if you have something like h of g of x, that's equal to h g of x. That's equal to h of g of x. Okay, so this is basically you do g first and then you do h. So an example of this is, say you have f of x equals 6x plus 2. So the function f takes x, it multiplies it by 6 and it adds 2. That's what the function does. G of x, however, will just cube x. Okay? So the next thing they want you to do, they want you to say find f of g of x. So basically find the composition. Sorry. Find the composition. So what I want is, I want f of x, which is equal to 6x plus 2. I want to have f of g of x. So that's just equal to, by definition, 6 of g of x plus 2. G of x is equal to x cubed. So just plugging that in, I get 6x cubed plus 2. Like that. Okay? So that's if you do g first and then f. But what happens if you do g and then f? What happens? So again, this is equal to g of f of x, like this, which is going to be f of x cubed. Because remember, g gets what you give it and cubes it. So in this case, I'm giving it f of x and therefore it cubes f of x. So this is equal to 6x plus 2 cubed. The main thing to note here, this is the first one, this is the second one. F of g is not equal to g of f. So the order depends. So, and it does matter. So you actually can't just willy-nilly do one and the other. Okay? So hopefully that makes sense to everyone. So that's the two of them. Okay? Now, okay, so you also have some mapping diagrams, which will look like this, and they will ask you which of these are functions. So something like this. It'll say you go from here, 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 and this gets mapped. So again, these are your inputs. And these are your outputs. So you get this, goes to this one also goes to this one, and then this one goes here. So is this a function? Yes or no? The answer is yes. The reason is because remember, the only thing you have to satisfy for a function is that if you give it a number, it only gives you one more number. If I plug in this number here, does it give me just one number? Yeah, it gives me this. If I plug in this number, does it give me one more number? Yes, it does. If I plug in this number, do I get another number? Yeah, I do. Now, if I go to this one, so 1, 2, 3, 1, 2, 3. So this one now goes to here. This one also goes to here. This one goes to this one, and this one goes to this one. So now, is this a function? No. The reason is because of this guy. So if you plug in one number into this, you get out two separate numbers. Okay, and so that's not a function. All right. So again, a function, so it's the same thing like a function on your phone. If you press the volume button, the volume goes up by 1. If you press the shut off button, it turns it off. That's that. So if you press it once, it does one thing, and that's that. It doesn't do 3 or 4. So in this case, this one is not a function. Okay. Another thing they can ask you is they can say, okay, which of these are functions? So this is the first one. This is the second one. And then this is the third one. So which one of these is a function and which one isn't? So here, if we look at the first one over here on the left, if I plug in a certain value of x, do I get a new value of y every time, or a single value of y every time? Yeah, I do. So this is a function, this is fine. The second one, now this looks weird, but what am I saying here? This point basically says that you have two different graphs. This one stops there, and it just jumps up to here. So again, this circle I left blank for the reason that if it's left blank, it means that if you look at the x values that are here, so this x value, it's not given this one, it's given this value. Okay, so just to specify, for this specific value of x, you're only getting one value of y. And so is this a function? Yeah, that's a function too. So that's completely fine. This one, however, is not a function. Why? Because if I go and draw a line down like this value of x gives me two values of y. And therefore it's not a function, because I have that 1x gives two values of y, and therefore it's not a function. Okay? So hopefully that is all okay. All right. So now we've already gone over linear equations and quadratic equations in previous chapters, so I think I'll leave that one off. Now the next thing I want to do is completing the square. Okay. So completing the square. How do you do that? So that's specifically on a quadratic. So it's where you have something like h of x or y equals ax squared plus bx plus c, and you change it into this form. So y equals a into x plus b over 2a to b squared plus c minus b squared over 4 A. So now, this is a formula that isn't in your log tables, but if you would like to learn it off, you absolutely can. Because this is just how you complete the square. Okay? So basically what you want to do is, you want it to look like, no, in some of your books, they might use H and K instead. So they might say, oh, so this is the form you want it in, but you can also write it like this, that y equals a into x minus h squared plus k. Because then this gives you a vertex or a turning point of hk. Okay, so what does that mean? Let's say we have f of x is x squared minus 4x plus 7. That looks something like this. Where the lowest point here is equal to 2, 3. So remember, quadratics always have one turning point, or a center point, which in this case is here. Okay, and it's equal to 2, 3. So that's basically what we're kind of saying here. Okay, that if you complete the square on a quadratic, then you can basically get where the turning point is. Okay, so now I'm going to complete the square on a couple of them. Okay, so if I complete the square here, so it says f of x. So f of x, you can also write this as f maps x to this. Okay, so it's the exact same thing as x squared minus 12x plus 36. So again, you get x squared minus 12x plus 36. In this case, there's a 1 in front of the x squared. So you can just leave that the way it is. Okay, so typically you divide out by the number in front of the x squared in the front two. Okay, but in this case it's a 1, so I can just leave it the way it is. You do x. You divide this thing by 2. Okay. You square it and you add c. Now this has to be equal to this. So you multiply this out and you're going to get x squared minus 12x plus 36 plus c. Like that. Okay. So in this case, this thing has to be equal to x squared minus 12x plus 36. And this means that c has to be equal to 0. Why? Because the x squared and the x squared cancel, the minus 12x and the minus 12x cancel, the 36 and 36 cancel. So I'm just left with 0, so c equals 0. And therefore, I have that x squared minus 12x plus 36 is just equal to x minus 6 to be squared plus 0. And therefore my turning point, remember, it's x minus h to be squared plus k. Your turning point is hk. So in this case, your turning point is 6, 0. So if I were to draw this out, it would look something like this, where this point here is 6, like that. Okay, so hopefully that's all right. So the next one, it says write these in completed square form. Okay, so I'll just do one more of these and then I think I'll leave it. So it's 13. So y equals 13 minus 4x minus 2x squared. So again, that equals, I'm going to take minus 2 out of it, out of these ones, okay? And I get x squared plus 2x plus 13 on the side, okay? Again, this is equal to minus 2 into. So it's x. It's, again, you divide this by 2 and you get plus 1. You square it and then you add c, okay? Now, you multiply this bottom thing out. So you get minus 2x squared minus 4x minus 2 plus c, and that has to be equal to minus 2x squared minus 4x plus 13. Okay, so the top thing up here. So again, this cancels with this cancels with this. I'm left with c minus 2 has to equal 13, so c has to equal 15. So if we plug that back up here, we get that y is going to be minus 2, x plus 1 to be squared, plus 15. And this means our turning point is minus 1, 15. Okay, so in this case, this is a downward facing quadratic. Why? Because the number in front of the x squared is negative, and therefore it's downward facing. So it looks something like this. So minus 115, that's the turning point, but it's downward facing, so it look like this. Like that. Okay? Where that's minus 115. Okay? So hopefully that's all okay. The very last thing that I'll go over is cubic functions, and then I think, and maybe I might do exponential as well for a small bit, and logarithmic. Okay, so for cubic functions, you have y equals ax cubed plus bx squared plus cx plus d. There's only 4 ways these can look. So if a is greater than 0, it can either look like this, where the right arm points up, or it'll look something like this. Again, where the right arm points up. If a is less than 0, then it'll just do the opposite, where the right arm will point down, or again, it'll do something like this. Again, where the right arm will point down. So just to be clear, if the number in front of the x cubed is less than 0, the right arm will point down. And then if a is greater than 0, the right arm will point up. Okay? So it'll always look something along the lines of this. Okay? So I think that's all for those. I'll do one exponential one. So here it says, so you have a graph and it basically says that it's this, okay? So you have something like this. This point here is 3. And it also goes through, it also goes through where this is 1. It goes through 12. So this height here is 12. Okay, so y equals ab to the power of x. Basically figure it out. So the way you do it is you'd say, okay, well, first of all, I know here, so again, it says that b is greater than 0. So this is when x equals 0. So when x equals 0, y is 3. So if I plug in 0, I need to get y equals 3. So that'll be a, b to the power of 0, and that means that 3 is equal to a. Okay? So y is going to be 3 b to the power of x. We also know that if I plug in 1, I have to get 12. So 12 is equal to 3 times b to the power of 1, which is just b. So in this case, b is equal to 12 divided by 3, which is 4. So y is 3, 4 to the power of x. So that would be this graph here. Okay? So not too bad, just using your information from the graph and just plugging back in. Okay? And then finally, how do you graph logarithmic functions? So it'll be something like this, okay? So if you have f of x equals a to the x, and then g of x is log to the base a of x, what you have is, you'll have something like this. So either if a is positive, then f of x to the ax will look something like this. Again, you can draw the y equals x line. Okay, sorry, you know what? I might just do a different color for these ones. So if this one, it looks something like this. And then if it's this one, it'll look the exact mirror, sorry. It'll be the exact mirror image of it, okay? Like that. That's if a is greater than 0. And then if a is less than 0, if a is less than 0, then basically this purple or pink line will basically flip and it'll go to this. Okay? But again, you always draw your y equals x line. And then you just draw the mirror image of it. Okay? So the mirror image in this case would be something like this. Yeah, it would look like that. So again, it's just being flipped over. Again, why? Because this is the inverse. Okay, so by inverse, what do I mean? I mean that f of g of x equals x. So basically, if you give x to g and then give g to f, it will give you back x. And also g of f of x also equals x. So this is just to say that log to the base a of ax is equal to x, and also a to the power of log to the base a of x also equals x. So in both cases, if you give x to f and then give f to g, you end back with x. Okay, so that's why it's an inverse, and that's why when you're drawing logarithmic functions, you basically draw the exponential of it and then just go across the y equals x. Okay, so hopefully that's all right. The next thing I'm going to do transformations and then do some injectivity, surjectivity, and bijectivity as well. But until then, I will let you off, and I'll see you in the next video. Thanks very much for paying attention.